last week regarding with your finals here. So make sure you guys practice on this. Watch out. This is so please read the information here. So so here's the information for your finals. Your final is the following Wednesday, December 15th. So not this Wednesday, but the next Wednesday. Is from 2 to 3:30. It's in CLA 116. It will cover 7475. 81 to 84. I think we might able to squeeze 8.6 in there. So I think we might able to cover 8.6 because we will cover 8.3 and 8.4 today, and then 8.6 on Wednesday. So so we were able to cover these sections here. There will be 10 to 12 questions in your finals here. You are allowed to use either graphing or scientific calculator in your finals here. So you can use either one or both of them. You're allowed to have one page of written front page of notes. So anyone, you can do whatever you want in the one page of notes. I will recommend you to do the unit circles, do the formulas for sum and difference, and all the formulas, the double and the half angle and the sum to product to sum, that formulas that you get in 7.5, and then that law of sine, law of cosine that you guys got in chapter 8. And then today we talk about your vectors. So there will be some formulas and definitely formulas in 8.6. So there are formulas here, quite a lot actually. So please, I would recommend you to use that one page of notes here to put your formula in there. The review is right over here. So the key is also posted there. We will review on Monday. So today we will finish the two sections of 8.4 and 8.3 and 8.4. And then on Wednesday, we'll do 8.6. And then on following Monday, we will review for your tests, same time, 2 o'clock to 3:30. And then after that, we will talk about the review finals that we have here. And then on the Wednesday after that, you'll be taking your finals here. So anyone have any questions with your finals here? Anyone have any questions? Finals questions? So so again, today, Monday, we will talk about 8.3 and 8.4, which is all about vectors. And then on Wednesday, we will talk 8.6. And then on next Monday, we will review for your finals. And then on the Wednesday, you will have your finals. Okay. For your online homework, there are 3 online homework due today, Wednesday. So 7.5, 8.1, and 8.2 is due on Wednesday night. So this coming Wednesday, which is the 8th. And then the last 3, 8.3, 8.4, and 8.6. This is due on Tuesday, the 14th, the day before of your finals. The finals is on 15th, so this is due on the Tuesday. Usually our homework is due on Wednesday, but this is only due, this will be due on Tuesday. So there are 6 more homework left. So this is the last, hua that you're gonna do here. So then after that, you will have your tests here. Anyone have any questions for me before we start 8.3 and 8.4? Okay, so we're going to talk about 8.3 here, about vectors. So what is vectors? Vectors in this case is where you have involved with both magnitude and directions. We will call that as vectors. How do you write vectors in your homework or in your vectors is written down as P over Q with an arrow on it, where P is called the initial point and Q is called the terminal point. The magnitude, which is the double absolute value of PQ, is the distance from P over Q. So we will use the distance formula. So let me tell you what are vectors here. So vectors must have two, involved with two stuff, two units. One is magnitude and one is direction. So let's say that you got a P and the starting point, and this is Q. So this is vector PQ. So we draw a little arrow on it. So that means P is the starting point, Q is the ending point. The magnitude is the distance from P over Q. So the distance between this is what we call as your magnitude. And how do we symbolize this? Is double absolute value PQ, like that. So this is called a magnitude. And in order for us to find the magnitude, we use the distance formula. The distance formula is the square root of your x coordinate squares, x2 minus x1 square, plus y2 minus y1 square. Okay, so as you know that this is all going to be like coordinates. So this will be your x1, y1. And then this will be x2, y2. So in order for you to find the distance or the magnitude, we call it. Now, the direction, we'll talk about that later on. So if you have two vectors that have the same magnitude and same direction, we call that as the vectors are equivalent. So as you know that, let's say this is vector PQ. And I got one that is like this. This is vector MN. These two vectors are equivalent if they are the same, if the distance is the same distance and the same direction. Okay, so this is going to the northeast. This is also going northeast, and then that in order for you to measure direction, usually we measure the angle here. So that means the angle that is formed here is the same angle and the distance is the same. So the length is the same. So we call these two vectors considered as equivalent. Okay, and if you set this vector in a plane of xy plane, okay, so another kind of vector is if I put this vector PQ or MN into the xy coordinates plane, where my P in this case is your origin, and your Q is the one that is the ending point. So if I translate this into here or MN, okay, then this vector is no longer called as PQ. This vector is called as vector V. So when I put your vector, the initial point or where it starts point in the 0, 0 and put it in the XY coordinates plane, this is called a vector V in this case. So vector V, vector PQ, and vector MN is called equivalent vector, means that the directions is the same direction and the distance is going to be the same distance. Okay, so so in order for you to find, in order for you to write this vector V here, you have to write this as a lowercase and bold-faced letter. So when you guys do this in my homework, so this is something that I always tell my students. So when you do this question in your homework, when you do vectors homework, you have to bold the vector U and the vector V or vector W. So how do we bold this in your vector? See, this is all bold, right? You can see by looking at that, they're bold. So in order for you to bold this, if you want to write it, you have to use the cow pad here. If you go under vectors, you see all these I, bold, I, j, k. So you have to type using these vectors here. You cannot just type I here, they will mark you wrong. You have to use the bold I like this, okay? So this is something that I really want you guys to understand this, especially when you guys do this section for 8.3 and 8.4 homework. When you write the vectors, make sure you write in the bold form. So don't write in just, you know, a normal form. And because in here, I cannot bold this, because I can bold, it's very difficult to bold, especially in the test. You bold means you like, you know, keep on writing this. So for me is I don't bold it like that. So I just put a little line on top. So this is considered vector. Say, so you can either bold it, or you can put the line on top, or you can put the arrow on top. They are all the same thing, but bolding is very difficult, especially in the test. But in your online homework, you can bold it using the cow pad. But in the homework, or when it's written homework or your test, usually we just draw a line on it. Okay, that's symbolized as vector. So that's what we're going to talk about. Okay. In vectors, there are 3 different forms. So you usually use U, V, W, and I and J. So that is usually the vector that we use. There are 3 forms you can write in vector. One is called the component form. 2 is called the linear combination form. And 3 is called the direction form. So there are 3 ways to do it. So you need to know how to write them in each one of these ways. Okay, so let's talk about component form. Component form is where you write this where your P or your original is at the 0, 0. So your initial points is at 0, 0. Okay, so your initial points is at the origin and is in standard position. Standard position means you measure from the XY. So this is called a standard position. Okay. So if you have a vector, P with the coordinates P1 and P2 in the initial point, and the Q1 and Q2 is the terminal point for Q. So the vector P in this case is Q1 minus P1, Q2 minus P2, or V1, V2. And class, I just want to point out to you, in order for us to write this component form, we use less than and greater than symbols. We don't use parentheses. So for example, in this case, if I have this PQ in this case, let's say this P is at the coordinates here. I go to the coordinates. Let's say the coordinates here is -1, -3. And the Q here is, let's say, coordinates of 7 and 5. Okay, we can write this in a standard form, and the standard form we call it as V is gonna be taking x2 minus x1, so it will be 7 plus 1, and then 5 y2 plus y1 3. So actually it's minus, okay, because it's your x1 and y1 is negative, so the negative become up to negative become positive. So this is going to be 8, 8. Okay, so this is how you figure out your vector PQ here. Is you take your x2 minus x1 and y2 minus y1. Now this 8, 8, if you translate or move this P into 0, 0, then this coordinates here will be 8, 8. This is what we call as V1 and V2. That means that this, we don't use it X. This is called a V1 line, and this is called a V2. So when you, if your P is not in the 0, 0 coordinates, we can make these PQ vectors as an equivalent vectors to put it in a standard form where it's going to be 0, 0. How do we do this is you take the x2 minus x1, y2 minus y1, and then you will get the 8, the number here. And this 8, 8 is actually is where you translate this vector PQ to the vector vector V here, where your P in this case is going to be at 0, 0, and this will be at 8, 8, because your X value in this case will be 8, and your Y value in this case will be 8. So we don't use X and Y, we just use V1 and V2. So that's what they do. It's very similar to coordinates, but they just use the V1, V2 in this case, sub X and Y. Now, in order for you to find the magnitude of this or the distance of this, you just need to take the square root of adding of this. So 8 squared plus 8 squared. So this is how you find the magnitude, is you take the V1 square and the V2 square, you add them and take the square root of it. This is square root of 64 plus 64, which is 128. Okay, so this is the magnitude of, magnitude means the distance. So the distance from P and Q here, the magnitude is root of 128. So this is given us by this formula. So the magnitude of V in this case is V1 squared plus V2 squared, and then take the square of it. Now, if this magnitude is exactly 1, we call that vector a unit vector. If your magnitude you found is exactly 0, we call this as a 0 vector. Okay, so this is how we figure out your component form here. And once you get into component forms, we can add the vectors. How do we add vectors? Is if you have vector U is U1, U2, and vector V is V1, V2, we just, if you want to add this, some of it, you just add your first component, and then you add the second component. If you want to multiply this with a scalar of K, K means, scalar means fixed number, then you distribute the K into your vector U. In this case, you will get KU1 plus KU2. So it's very similar to the number sense that we use. I'll just make sure that you only can allow to combine the first component, which is the 1, and the second component when you add or subtract. Okay. So the last thing we'll talk about here is unit vector. Then we do some examples here. In order for us to do the unit vector, if you want to find any unit vector, you take the vector divided by its magnitude. Then you get yourself a unit vector. So for example, in this case, we know this is our vector V is 8, 8. Our magnitude is root square of 128. So if I want to find the unit vector of this V, what do I do is I take this 8, 8 vector V, and then I just, so vector V over by the magnitude of it. So in this case, it will be 8, 8, because our vector V is 8 over 8. The magnitude, this one we need to reduce it because this is 64 times 2. So this is 8 root 2. So this will be 8 root 2. And then you can divide this. So the 8 will divide each other. So in this case, you will get 1 over root 2 and 1 over root 2. So this is the unit vector for this case. So if a question is asking for unit vector, you take the vector V divided by the magnitudes. Okay, so this is kind of the formula that we will learn here. Okay, now so we're going to talk about component form. So for question 1, you want to find the component form of the magnitude of the vector V, given us the initial point is 1, 3, and the terminal point is -8, -9. So in order for us to find the component form of this vector V here, so since they give you these 2 coordinates, so we need to use the formula of this. Okay, so question 1 is very similar to what we just did over here. So this is 8.4 question. This is 8.3. So in order for you to do the first question, they're asking for the for the component form. So too many windows. So first question is given us that the initial is 1, 3. And your terminal side is -8, 9, -9, -8, -9. So you need to find what is the vector v here. So do not forget, vector v is taking the first component minus the second component. So this is your x1, this is your y1, this is your x2, this is your y2. So it's always terminal minus your initial. So this is one I always tell my students, is always terminal minus your initial. So if you flip this around, you will get it wrong. So terminal in this case is x2 minus x1. And then this is y2 minus y1. So this, you just replace the numbers. So x2 in this case is -8 minus 1. Y2 in this case is -9 minus 3. So this is your, then you just figure out using your calculators. Or so this is -9 and -12. Okay, so this is vector v. So vector v is given us with the component form of -9, -12. And the question also wants you to find what is the magnitude of it. So in order for you to find the magnitude, you just take the square of the first one plus the square of the second. So this, and then you square root it. Okay. So the square of the first one is 81. This is 144. Square of 12 is square of 12 is 144. So 81 plus 144 is what? 225. So add these two and then take the square root of it. So this is 15. Okay. So the answer is the component form for vector v is -9, -12. And the magnitude is 15. Now, if the question asks you to find what is the unit vector v here, this question didn't ask, but if a question asking to find what is the unit vector v, you just take the vector v over by its magnitude. So in this case, you take -9, -12, and then you divide this by 15 each because our magnitude is 15. So you take this divided by that. So you will get -9 over 15 and then -12 over 15. And you reduce this. So your answer is -3/4. 3/5, sorry, 3/5 and -4/5. So this is what we call as a unit vector. Okay. Now I know the question didn't ask for it, but if a question do ask for it, you need to take those two and divide it. Anyone have any questions on the first example we are doing here? Next. So if a question is given us a picture, you have to sketch what is -v, what is 5u and u minus b and u plus 2b. So we can actually do vectors by drawing. So let's say that vector u is this way. It's hard to let me draw it in here so you can see it. Sometimes it's so hard to draw with it's gonna be hard to draw. So let's say that, let me do an example of your homework, then you can see what's going. There you go. So this is vector u and this is vector v. Okay. So the question here is asking for 3v. What is the graph for 3v? Is you take this v and you triple it. So let's say this is your v. And the question wants you to graph 3v. So what you do is you just multiply this 1, 2, and 3. So this is 3v. So you just like duplicate it 3 times. Okay. So your answer is going to be in this case. So you duplicate 3 times. Okay. What is u plus v? So if I give you, so v means 3v means we like zoom or make it longer 3 times, 3v. Let's say you want to find u plus v, because the question is asking. So this is v and this is u. Okay. So in order for you to draw u plus v, you have to draw me a parallelogram. So a parallelogram means is the sides has to be the same, and so both sides have to be same. So this is v and this is u. So and then you draw right in the middle from end point here to this point. This purple one is this purple. The orange one is what we call as u plus v. Okay. So in order for us to have a vector u plus v, you draw the vector u, and you draw the vector v, and then you draw the parallelogram of it. So that means same length for this case, same length. And then you just go from the starting point to where they meet. This is u plus v. Okay, so this is how we do u plus v in this case. It's always connect from one end to another end of the parallelogram. Okay, so usually this will be u plus v, because if u is here and v is here, if you draw me a parallelogram, so u plus v will be right over there. What happens when I ask you for u minus v? So u minus v means that, let's say this is u, this is v, sorry, and this is u. So in order for us to figure out minus means it goes completely 180 degrees direction. So this is positive v. So to find a negative v, this is a negative v. So that means it goes completely 180 directions. So if you want to do u minus v, you have to draw me the parallelogram again. So this is your u, and then this is your negative v. So, and then you connect from one endpoint to another endpoint, the blue one. So this is going to be u minus v. So as a picture, if you want to do the minus, what you do is you just reverse the vector 180 degrees, going 180 in different directions. And then after that, draw me a parallelograms and then connect one end to another end. So this is how we do the u minus v. If you want to do u plus 3v, then what you need to do is you have to extend this 3 times longer, the v. So 1, 2, 3. So this is 3v. And then this is u. So what you do is you also extend this 3 times longer. And then this is the vector v here. So, and then you draw connecting from one end of the point to the other end. So this green line is going to be u plus 3v. So make sure you guys know that we can also draw, you can also do vectors using graph, okay, which is a bit, for me, it's a bit more trouble or cumbersome, because you have to extend it and you have to watch your coordinates and everything. So if I give you a vector uv like this, if I want you to add, so this is easy. You just literally add the first component and add the second component. So example here is the first question asks you to, is u is 2, 1 and v is 1, 5. So if you want to do u plus v, then you just do this. So this is question number 3. So vector u in this case is 2, 1. Vector v in this case is 1, 3. So in order for you to add this vector, you just add them up. So like adding the components. So the first is 2 plus 1. And then the last is 1 plus 3. So you just add them up. So you will get 3, 4. So this is what is when you add this without drawing the picture. So you just add the first component and add the second component. So this is u plus v. And if a question wants you to find u minus v, what do? Is you just subtract them. So you take 2 minus 1 and then 1 minus 3. So this will become 1 and negative 2. So this is u minus v. And if a question wants you to write this as 2u minus 3v, so what do you do here is you multiply the 2 into the u. So the u is this. So you multiply 2 inside, you will get 4,2. Okay, so 2u means you take the u component and you times it by 2. Minus with 3v, so you multiply this component by 3. So it becomes 3,9. So kind of distribute the 3 into the first and second component. And then after that, you subtract these 2 out. So 4 take away 3 is 1. 2 take away 9 is -7. So this is how we do 2u minus 3v. So it's pretty much very simple. What you guys like, very simple addition and subtraction and distributing that you guys learn in very basic algebra. But the only thing is this is in vectors, so you have to write this in that little, up and the less and greater sign that we have. So this is what if a question wants you to add the 2 components. What happens? Question 5 is they want you to find the unit vector. So again, the formula for unit vector is taking the vector v divided by its magnitude. Okay, so vector v in this case is 5 over 5 and -12. So you need to find what is the magnitude of it. So in order for you to find the magnitude, you square the first one, which is 25, plus, always plus, you square the second one. Now, when you square a negative, it's become positive. So this is 144. So do not put a negative 144 here. You will get it wrong. So because every time when you square a negative, it's always positive. This will give us square root of 169. If you take your calculator, root 169 is actually 13. So now we just plug the vector v that we have here, and the magnitude is 13 into this formula. So you will get 5 over 13 and -12 over 13. So this is what we call as the unit vector. So it's not too difficult if you do this. Again, formulas are the unit vector formula is given us by this formula, and you cannot switch it around. Okay, so this is what we call as a component form. As I tell you early on, your vectors can be in 3 different forms. So component form is the easiest one we use a lot. Next is a linear combination form. A linear combination form is written down in the form of V1I plus V2J, where V1 is called the horizontal and V2 is called a vertical, like X and Y. V1 is the one that goes horizontal, X and Y, X, and then V2 is the vertical that goes up and down, like a Y. So this V1 and V2 is exactly the same V1 and V2 that you have in your component form. So in order for you to write a component form to a linear combination form, it's very easy. You just take the you just remove that less than and greater than symbol and replace it with I and J. And don't forget, this I and J is in bold vector form. So when you put this in your online homework, make sure you put the I and J in the bold form. So for example is, if you have the component form is 3, 4, I can write, let's say 2, 1 here. Let's do 2, 1 first. I can write this in a linear combination form. Then this is 2I plus J. So 2I plus J is the same thing as 2, 1 in component form. This one, I will written down this as I plus 3J. And don't forget class, the IJ that you use here, make sure it's bold because they are vectors. Then when you add this, you will get 3I plus 4J because it's the same thing as 3, 4. You just replace the 3 with the 3I and the 4 with the 4J. This will become I minus 2J because your sign is negative. This will become I minus 7J. So it's very easy to write, to convert a linear form to a component form or vice versa. So they are very similar. You just need to change your less than greater than to become IJ. Okay. So example will be like question number 4. Question number 4 is given us by u equals to 2i plus j and v equals to 3j. So if you want to add them, you just add combine like terms. So again, vector is not tough because it's new to you guys. So so that's the reason why that it sounds difficult, but actually it's not. So vector u in this case is negative 2i plus j. And vector v in this case is 3j. So you just need to figure out what is u plus v. So you just again add them up. Take your this and add it with this. So combine like terms. So unfortunately, there is no I terms to combine. So you still get negative 2i. But the j terms, you just add it, become 4j. This is 1 plus 3 become 4j. So this is your answer for u, vector u plus v. And usually in the class and in the test or in your homework, if you have it in a component form, then leave your answer in a component form. If your answer is a linear combination ij form, leave your answer. Do not write this as negative 2, 4. I mean, in my test, I still give you correct. These two are the same thing. But in your homework, if you give this, they will mark you wrong because the question is in the ij form. So make sure you give it in the ij form. Same thing with question B, you subtract them. So u minus v. So you just take this negative 2i plus j minus 3j because you just minus and then combine like terms. You got negative 2i minus 2j. So it's pretty much very straightforward type questions here. It's not that difficult. Then the question also wants you to find what is 2u minus 3v. So what you do is you just multiply all this by 2 and then you multiply the v by 3. And then after that, you subtract them. So when you multiply this by 2, you will get negative 4i plus 2j. And then when you multiply this by 3, you get 9j. And since the question wants us to subtract, then we subtract it. And then you just combine like terms, you get negative 4i minus 7j. So it's, again, class, not difficult. This section is a bit, if you do your homework, it's a bit more assigned here, but you can tell the works that we are doing here is pretty much straightforward type. Okay. Question number 6, which is the same as question number 5, is to find the unit vector. So in order for you to find the unit vector, you take the, if it's w, you just you use a vector w divided by its component. Okay, by the magnitude. So w in this case is 7j minus 3i. So in order for you to find the magnitude of this, you just take the numbers and square it and add them up. So you square the 7, you get 49. And don't forget, it's always plus. Every time when you do magnitude, it's always plus. And then you square the negative 3. This is positive 9. Okay, so what you do is you square your 7 and you square your negative 3. Okay, and don't forget, a negative when you square is always positive. So 49 plus 9 is 58. Can we reduce 50? Can we do 58? Can we square of 58? I don't think so. We can do anything with 58. Yep. So so what you do is you just combine this back. So you take this 7j minus 3i into here. So you just put 7 over 58j minus 3 over 58i. So you just I forget the square root because your magnitude is a square root. So it's 7 over 58j square of 58j minus 3 square of 58i. Now, for me in the test, this is your answer. Okay, I give you correct. But when you write this in your online homework web assignment, they will mark you wrong. The reason why they mark you wrong in this case is because when you write this in the linear combination forms, your I always has to come first than J. So this, the J comes first than I, so you just need to flip it. So this answer will be negative 3 over root 58I plus 7 over root 58J. So I just want to point out to you in your online homework, they are very picky. when you want to write this in a linear combination form, make sure that the I come first, then the J, because if you put J and then I, they will mark you wrong. Okay, so it's very simple stuff, but it's frustrating because you got the answer correct, but they mark you wrong because you forgot to move I and J around. Okay. So this question want us to do number 8 is asking us to write a linear combination forms using these 2 points. Again, the initial point is given us by -6, 4. And the terminal point is given us by 0, 1. Okay. So this is the same thing we just did last time on the first example. But in the first example, we do it in the component form. If you remember, the vector v is in the component form. So we can still do the same thing here, but unfortunately for this question, they want it in a linear combination form. So you just need to change to ij after that. Okay, so that's what we do here. Don't forget, always take the terminal minus the initial. So the terminal in this case is 0 minus the initial, so it's +6 because 2 negative, and then 1, same thing here, terminal minus the initial of second component, -4. So this will give us 6 and -3. Again, this is usually the answer for question 8. But since they want in a linear combination form, you just need to change this to become ij. So it's 6i minus 3j. So this is your answer for number 8. Okay. So my usually my advice to you guys is read the question carefully and figure out what kind of form do they want from you. Do they want it in a linear combination form, like I and j form? Or do they want it in a component form, which is that less than and greater than sign? So read the question carefully and they will tell you what form do they write. Like question number 9 here. They want you to write this in the component form, given us that v is 1/2 3u plus w. Given us that the vector u in this case is 2i minus j, and vector w in this case is I plus 2j. So what you need to do here, class, is substitute. So you just plot this vector u into here, and you plot the vector w into here. So what you need to do first, orders of operations inside the parentheses. So because there's 3u means you have to multiply this vector u by 3. So you will get 6i minus 3j plus vector w is just this, I plus 2j, and then you combine like terms. Once you combine like terms, you just multiply this by 1/2. So let's combine like terms here. You got 7i minus j. Okay, 6 plus 1 is 7, and -3 plus 2 is -1. And then you multiply by 1/2. So you got 7/2i minus 1/2 j. But again, this question does not want us in a linear combination form. They want this in a component form. So you just need to put the less than and greater than. So it's 7/2 -1/2. So this is your answer for this case. Very simple stuff, right? You notice that, oh, this is not too difficult. Not really. Careless mistakes is the one that I always see students doing, combine like terms, multiply by 3, watch for addition and subtraction. Those are the stuff that you guys knows about it. Okay, so that is how we do the first form and second form, which is the linear combinations and the component form. Now we do the third one, which is the direction form. So in order for us to do the direction form, theta in this case, we have a direction theta. Theta in this case is where it's a vector u, is an angle. that is measured counterclockwise from the x-axis of the U. So this is something that you guys learned before in the unit circle, because when you want to write something in a direction form, like this I plus 2j, it means that it will be in quadrant 1, where your x in this case is 1 and your y in this case is 2. Okay, so this is your theta. Okay, so this theta is what the angle that forms by this vector W, and it goes counterclockwise and start with the x variable, the horizontal, and then you x-axis, and then you go up to counterclockwise. In order for us to write this U in a direction form, you use, this is actually wrong. It's not sine theta, cosine theta. This is like a unit circle that you guys learned in chapter 6. X in this case is always your cos, and so this is actually switch around. So please switch this around. So your U in this case is cosine theta, sine theta. Okay. So in order for you to find this theta, you have to use the formula of tangent theta equals to sine over cosine, or B over A. So so you got sine, which is the J component or second component. Your cosine is your first component or your I component. So in order for us to find what is the value of this theta, we just take tangent theta equals to your second component divided by your first component. For example, for this kind of questions, if I want you to find what is theta is, the theta in this case is going to be the arctangent of 2 over 1. Okay, so 2 is your second component, 1 is your first component, and then you use your calculator to figure out what is arctangent of that. Okay. The only thing you need to watch out here is your quadrant. So watch out what quadrant is this. So when you and also watch out, do you want degree or do you want it in radian? So if I want it in degree, then make sure your mode, your calculator is in degree. So the arctangent of 2 in this case in a degree mode is 63.43 degrees. And we know this is a correct quadrant because 63.43 is in quadrant 1, and this 1, 2 is also in quadrant 1. But if you want to figure this one, this is the very special case, because if you want to draw what is 2i minus j, 2i means the component is positive 2, minus j means it's a negative 1. So this is the 2i minus j, but the theta that you find here is this theta, and we know this is going to be in quadrant 4. So this is the one that you need to watch out here, class. So when you find the theta here, you do the arctangent of the last component, second component, -1 over 2. And when you punch this into your calculator, the arctangent of -1 over 2, you get this as -26.57 degrees. However, the theta that we're supposed to measure is this whole theta. So this -26.57 is this, -26.57. So a lot of students get wrong in changing your into a direction form is because the quadrant, because -26.57 is in quadrant 4, but it goes clockwise. But what we want to go counterclockwise. So in order for you to find the theta in this case, you have to add 360 to it. So when you add 360 to it, then your answer in this case will be 333.43 degrees. So this is the correct one. This is the wrong one. So just want to be careful with you guys that if you found this in quadrant 1, this is good news. Everything is good. But if you want to figure out this in quadrant 2 or quadrant 3 or quadrant 4, you actually need to perform something to this. You not necessarily just grab that angle. And then, if it's in quadrant 4, you do need to add 360 to it. If you find out this is in quadrant 4, you have to add 360. If you find out you get in your origin is in quadrant 2, you will add 180 degrees. Okay, because it goes to the other one. If you want to go to quadrant 3, you also need to add 180. So you have to watch out carefully what quadrant it belongs to. And that is the main part of changing this into a direction forms. So this is the hint that I want to point out to you guys. It's very important. Watch out for the quadrant. Okay? This is the one that I always tell my students. Okay? So once you find your angles, so the direction form of a vector v here is the magnitude of vector v times the cosine theta I. I'm gonna put I in the next one. Plus sine theta j. So this is your. So you do need to find the magnitude of it and the theta. The magnitude we just talk about it is the first component square plus the second component square. Then take the square root. So this is the direction form here. You need the magnitude and the theta that we have. The theta is the one that you need to watch out for the quadrant. So finding theta, you have to watch out for this. Okay. Watch out for the quadrant. So this is where a lot of students get wrong in my test is they know how to find the magnitude, but the theta is the one that is messed them up. Okay. So let's take a look at some question here. So now this question wants us to write this in a component. This one, number 8. Find the magnitude and the direction angle. So this 10 is very easy because this is already in a direction form. So the magnitude in this case will be 8. And the angle in this case will be, the direction angle in this case will be 135. Okay. So and the direction angle, oh my God, what happens to my, something happens. So the direction angle in this case will be 135. So your magnitude will be 8 and your direction angle in this case will be 135. So if you have it in what we call as a direction form, the first number you see here is your magnitude and the theta, which is the angle behind here, that is direction angle. So this question wants us to convert component form from this given us a magnitude and an angle, you want it in the component form. So in question number 11, we need to write this in terms of the vector v in a direction form. So how do we write that in question 11 in that case? So the direction form is a little bit tough, but we'll be fine. We'll talk about that today. So so let's say that given us that the magnitude v in this case is 2√3, and the theta in this case is 45 degrees. Okay, so the vector v in this case is given us by the magnitude of v times with cosine theta I plus sine theta j. Don't forget, it's very similar to your unit circle, cos and sine. X is cos, y is sine. We can distribute this in there, so it's going to be the absolute the magnitude of v cosine theta I plus absolute value v of sine theta j. And since this is in a linear combination form, we can write this as a component form. You just need to drop your I and j. So this is actually is the vector v, the magnitude of v times cosine theta, and the magnitude of v times sine theta. So what we do is v is 2√3 times cosine 45 degrees. And then magnitude of v is 2√3 times sine 45 degrees. So this is how we change from given us a magnitude and a direction to a component form. And we just multiply this up. Cosine 45 degrees is √2/2. Same thing with sine 45 degrees is √2/2. This is where we learn it from the unit circle. And then the 2 and 2 will cancel. So what we get is √6. And this will cancel. This is also √6. So the vector v in a component form is √6 and √6. And the question also wants us to sketch this. And how do we sketch this is you just, this is 0. So from here to here, this is √6. And from here to here is also √6. So this is your sketch, your vector here. That means your x component or your first component is √6. And your second component is also √6. And if you look at the direction here, this is going to be 45 degrees. Because the question given us is 45 degrees. And if you measure how far the length of this vector, this length is 2√3, given us by this. So this is how you sketch this graph, which is pretty much simple here. It's not that difficult. Okay. So what is this used for? Okay, so what kind of questions or what kind of word problems is this used for? This is used for force. Okay, so what I mean by force here is, let's say that you got two forces pulling. One force is pulling from here, and one force is pulling from there. Okay, so imagine that you try to move a table or something else. Okay, and let's say you got two people moving this table. This is your table here. Okay, and one person is pulling this table exactly on the x-axis, and another person is pulling, on a 70 or 80 degrees. Okay, and it has a magnitude. So this table will move based on, if you do this, if you draw what we call it as a parallelogram. This table will move into this direction. This is the direction, and the magnitude is the how heavy is the table you can move. Okay, so this is kind of questions you get a lot in your homework and your test. Is called the resulting force. Okay, so what is a resulting force? Resulting force is where you take your first vector and you add it with your second vector. So this is what we call as your resulting force, V1 plus V2. Okay, so so this is use it a lot in your physics class. So this is when you guys try to move two things at one time, and then how heavy is your force in this case. Okay. So question in this case is that number 12. You need to find the component form of the sum. So given us that the magnitude in this case is 20 and 50. So in this case, if I want to draw the picture in this case, and the direction for the angle U that is 20 is 45. So that means that this is vector U is 45 degrees from here, and this move in the magnitude of 20. That means the length of this is 20, and we got a vector V. Vector V is 180. 180 means exactly on the x-axis. This is vector V. And this is going to be 50. Okay, so you need to find what we call as the sum. Sum means the resulting force. So how do we find the resulting force? First, you have to write this in the form of the U and the V. So this is the formula that we use. So in order for you to find what is vector U in this case is based on the magnitude and the angles. So the magnitude in this case is 20 times cosine 45 degrees. And then 20 sine 45 degrees. And we know 45 degrees for sine and cosine is √2/2. So this will cancel, become 10√2. And this 2 will cancel with 20, become 10√2. So that means that for vector U, the component form for vector U is 10√2 and 10√2. Now we go for vector V. So vector V, we also use back the same formula here. So it will be 50 cosine of 180 degrees, because this is go flat 180, and 50 sine 180 degrees. And then you use your unit circle that you guys learned in chapter 6. Cosine 180 is 1. Sine 1, not 1, negative 1, sorry, because it goes that way. So cosine 180 is -1. Sine 180 is 0. So this is actually is -50 and 0. So this is for, I use parentheses, it's less than greater than. So this is for vector V. So now we know vector U is this, vector V is this, and now we want to do the resulting. So resulting means you add them. So when you add this, you just take your first component and you add it. So it will be 10√2 minus 50, because this is your first component. You're going to add it. And then you take your second component and you add it. So 10√2 plus 0. So you get 10√2. So that means that if I want to draw a parallelogram here, this is your U plus V. And the coordinates for this is at 10√2 minus 50 and 10 for the x-axis, and the y value in this case is 10√2. So this is how you find the what we call as the component form of the sum of U and V. So this is the sum. Now, if you want to find what is the magnitude of this this sum, so you just take the the first component, you square it, and you square the second component. So this is more on the calculator side. So in order for you to find what is the magnitude of this component form, U plus V, the resulting form, you take this thing, this first component, and you square it. And you take the second component and you square it, and you add it, and then you take a square root. So this is mostly based a lot on calculators. So for this kind of questions, usually I would change this into a decimals. So what is 10√2 minus 50 is? So this will become negative 35.86, something like that. And then what is 10√2 is? 10 times √2 is 14.14. Okay. So what we do here is, in order for you to find what is the magnitude of this, I just square this fellow plus the square of that fellow. Again, don't forget, when you square this, this is a positive. So what is 335.86 square plus 14.14 square? And then you take the square root of it. So this magnitude is going to be 38.55. So if a question is asking us to find what is the magnitude of this resulting force, you just take the first component square plus the second component square and then square it. And don't forget, when you square the negative, it's always positive. Sometimes the question also wants you to find theta. And what is theta? Theta is the angle formed from the x-axis to the line u plus v. So in order for us to find theta, this is actually the arctangent of the second component, 14.14, over by the first component, negative 35.86. Sorry. So it's always like that. To find your find theta, you always take the second component divided by the first component. Okay. Just watch out for quadrant. So figure out what quadrant it is. We know this is quadrant 2. So when you do this, the arctangent of 14.14 divided by negative 35.86. This came out to be negative 21.52 degrees. Again, this is a wrong answer because negative 21.58 is right here, 52 degrees. This is the data that we're talking about. But since this is in quadrant 2, the data that we have to find is this red one. So since this is in quadrant 2, you actually have to add 180 degrees to it. Okay, so that's why if you a lot of students get wrong in your homework and your test is they forget to figure out what quadrant it belongs to. So once you add 180, so this data in this case will be 158.48. So this is the correct data representation here because 158.48 degree is in quadrant 2. So that means this angle is 158.48. So so this is how you find what we call as the magnitude and the direction. Okay. So if a question is asking you to find this, this is what you have to do. Okay. So what is that telling us is, let's say that you have let's say you are moving a table, okay, and you are moving this box or table. One person is carrying this 20 kilograms or 20 pounds on the 45-degree angle, and the other person is carrying it on 50 on 180 degrees. So where is this parcel or table or box will go? This box will go this direction, and it will have it is 158 degrees, and the box has to be around 38.5 pounds. So you cannot move heavier than 38.55 pounds because that is the highest you can get. Okay, so if your table or your box or whatever you try to move is more than your magnitude, your box will not move. That means you need to either add more strength or add more pounds into your U and V, then your table will be moved. So this is used a lot, like when you move things, gravity and stuff, like elevators, when you move up and down. These are all the forces, we call it, that will use this a lot in vectors. So that's why you need to know this kind of work. Okay. Anyone have any questions on this section here on 8.3? It's a lot. This is very important, that one I draw in box, the purple box here. This is called we call this as your component form, because we have a less than or greater than using magnitude and direction. So when you guys do this in your test, if I give you magnitude and directions, you're going to write this in the component form, like question 12. This is the one that you have to do. Okay. So this is the type of questions you get, the work problems here. Forces with magnitudes of 125 newtons and 300 newtons are act on a Hooke. So on the x positive. The angle between the two forces is 45 degrees. So we got, so we will have one that is 125 and one is 300. So let's say that this is 125. And because 45 degrees is here, this is 300. This is 45 degrees. So this is what the picture looks like. You try to move this. So so we got two angles here, two vectors here. This is vector u, and this is vector v. Okay. So the question here is to find what is the direction and magnitude of the resulting force. So resulting force means that if you draw a parallelogram, this red line that you see here is what we call as your resulting U plus V, the resulting force. But you have to find the magnitude. Magnitude means the length of this. So what is the length? And you also need to find the direction theta. Okay, so the question is asking you to find those two things. So the first thing you need to do, class, is to convert the vector u and v into what we call as component form. So you take the magnitude 125 times with cosine theta. Now, because this vector u is act on a x-axis, this is a 0 degrees. Okay, so this is a 0 degrees for this case. Because the angle is 0 degrees, is because this vector u is on the x-axis, and x-axis means your angle is 0 degrees. The 125 is the magnitude of this. So we know that cosine 0 is 1 and sine 0 is 0. So this is actually 125 0. Because 125 times 1 is 125. 125 times 0 is 0. So this is the vector u here. Next, we need to find what is vector v. Vector v is the same thing, but this time the magnitude is 300. But your angle is 45 degrees. So it's cosine 45 degrees and 300 sine 45 degrees. So for vector v, we are doing 45 degrees here. So 45 sine and cosine is √2/2. So when you multiply 300 by 2, you simplify this to become 150 √2. Because this will be simplified to become 150. And same thing over here, that will become 150 √2. Because 2 and 300 reduce to be 150. Okay. So this is for vector v, and that's for vector u. Now we need to find the resulting u plus v. So what you do is you just take this, add up. So this will be 125 plus 150 √2. And you add the second component. The good news about second component is that is 0 plus that. So you get 150 √2. So this is what we call as this vector u plus v is going to be here. So you can use your calculator to figure out what this is. So we take 125 plus 150 times √2. So this came out to be 337.13. And then this is 150 times root 2. So that one came up with 212.13. So now the question is asking us what is the magnitude. So in order for us to do the magnitude is you take this number, the 337.13, and you square it, plus the second component, 212.13, and you square it. And then you square it. So just take this square and that square, and then take a square. That's your magnitude. Okay. So what you get? So you will get 398.32 newtons. That means this box or this things that you move is going to be around 400 newtons heavy. So Newton is like using gravities. So if you are if this box is heavier than 400, you're not able to move this box. And then the question also is asking for the theta. So in order for us to find the theta, the direction, you do the arctangent of the second component, 212.13, over by the first component, 337.13. So this is usually in degrees. So you probably set your calculator in degree mode. So this will be 32.18 degrees. And the good news is this is in quadrant 1 because the 45 degrees is in quadrant 1 here. And this is also in quadrant 1. So that means this, you do not need to add 180 or 360 to it. This is your direction, and this is your magnitude for this question. So this kind of questions you will get in my finals next week. So make sure you guys kind of know what to do with this. It's not that tough. It's very heavy on calculator piece. Make sure you guys know how to convert this into a direction form. And then after that, add them up and then change it to decimals and then find the magnitude and the directions. And the direction, just be careful with the quadrant. Because your calculator do not provide you the correct quadrant as your picture. So usually the pictures is given to you in the test, so you do not need to draw the pictures. Right, I want you guys taking attendance, so go ahead and put present here in attendance. So that is the vectors of 3 that we talk about, component form, linear combination form, and the direction form. So there are a little bit about this. We just continue a little bit more formulas in here. So 8.4. So we were talking about the vectors forms in the dot products. Okay, and what is the most useful of these dot products? So what is a dot product of 2 vectors? A dot product U times V, or U dot V, is you take the first components of your vectors, you multiply it, plus the second component of your vectors and multiply it, and then you add them up. Okay, so this is the dot product. You add them up. Now this, when you add them up, you will get yourself a scalar. What is a scalar? A scalar means it's a number. Okay, you get yourself a number. So usually what we did so far here is when you do your examples that we did here, you got yourself mostly a vector. A vector means it can be in a component form like this. Ij is a vector form, or it can be like 8 cosine 135. This is also in vector form. The one in the component form 25 is a vector here. So everything we did here is vector. A scalar is just a number like the magnitude 9, 8, the magnitude 8, 2 root 3. Okay, like 125 newtons. Those are all what we call a scalar. Scalar is just a number. But when you dot the product of two vectors, you get yourself a number form. Okay. What is the useful of these dot products? There are two important usage of the dot product. One, you can find the angle between the two vectors. Okay, so if I give you two vectors, you can always find the angle of it. Is you do the cosine theta u dot v over by the magnitude of u times the magnitude of v. So you can actually find the theta between these two vectors using this formula. And also the second one is you can find if these two vectors are orthogonal. Orthogonal means perpendicular. And in order for us to have orthogonal vectors, the dot products here has to be equals to 0. So these are the two important features that when you do a dot product that we'll be using it. One is using the find the angle between the two vectors, and one is orthogonal. Now, so we will look at some examples here. So really fast. Question number 2 in this section, question 1, is they want you to find what is the dot product of UV, given us that U in this case is -25, and V in this case is -1, -8. So in order for us to find what is the dot product of UV, what do you need to do is take this 2, multiply that, dot means multiply, and then take those 2, multiply, and then after that you sum it. Okay. So -2 times -1 is 2. 5 times -8 is -40, and then you add it up. So this is -38. So this is what we call as the dot product. Okay. In order for us to make it to be orthogonal, this dot product has to be 0. But since you found this is -38, then you can say that vector u and vector v is not orthogonal. Okay. Again, orthogonal means perpendicular, means it forms 90 degrees. Okay. We can apply the same rules like what you did in the last section on the dot product. So in this case, at question 2 is given us vector u is 3, 3. Vector v is -4, 2. And vector w is 3, -1. So the question is asking us to find what is 3u dot v. So how do we find 3u dot v is we take the u and you multiply it by 3. So that means you will get 9, 9, because 3 times 3 is 9. And then you will dot this with vector v. Vector v is -4, 2. And again, how do we dot this? In this case is your first component, you multiply them. So you take 9 and -4, you multiply it, you become -36. Plus, always plus. And then you take the second component, you multiply it, you get 18. And when you multiply this, when you add this, once you finish multiply, make sure you add this, you get -18 here. Okay, so this is 3u times v. And the question is also asking is the result is going to be a vector or a scalar? Again, vector means your answer has to be in a component form or ij form. A scalar means it's just a number. So if you look at this question, you got -18. There's no component form. So this is a scalar. Okay. You will see some examples that has a vector component. Okay. Question B, they're asking you to do u dot v to v and then times W. Okay, so you have to follow the orders of operation. So you have to do the dot product first. So U is given us by 3, 3. You will dot with 2V. So now you're going to take the V and you multiply this by 2. So you will get -8, 4. Okay, so you have to dot this first, then you multiply with W. So when you dot this again, the first component you multiply. So 3 times -8 is -24. And then you add, always add your second component when you multiply. 3 times 4 is 12. And then you add this up, this will become -12. But then you still need to multiply this with vector W. And what is vector W is? Vector W is given us by 3 and -1. So now we need to distribute your -12 here. So what we get is -36 and 12. Now this is gonna be a vector form. The reason why this is a vector form, because this is in a vector as a component form. Okay. So this is how we figure out if your answer is in a scalar form, means just a number, or is in a vector form, which is going to be like this form. So when you get this less than or greater than, then this is the vector form. It's very similar to what we did. Make sure you do the follow order of operation, means do the dot first before you do the inside the parentheses first before you do the outside parentheses. Okay. Next, we're going to talk about is your angle. So question number 4A is asking us to find the angle theta between the two vectors. So in order for you to find this angle theta, you have to use the formula. And that formula is given us by this: cosine theta is equals to U dot V over by the magnitude of U times the magnitude of V. So this is the formula for to find the angle theta. And the question here is given us by U in this case is 3,2. And V in this case is 4,0. So what do we do here, class, is first you do the dot. So we have to dot the U dot V first. So you take 3 times 4, which is 12, plus 2 times 0 is 0. So this is 12. Okay, so we found out this number is 12. And then we do the magnitude of U. So magnitude of U means you take the square root of 9 plus 4, the square of the first component, add the square of the second component. This is square root of 13. So now we find what is the magnitude of U. And the last one is to find what is the magnitude of V. So in this case, it will be 4 squared, 16, plus 0 squared, 0. So this is square root of 16, which is 4. So times 4. Forget this, I'm multiplying. So what you do here is find out what is 12 divided by root 13 times 4. Again, because this one has 2 terms, you need to put parentheses on it for your calculators. And then once you finish it, you move the cosine over to become arc cosine. So now this is your theta value in this case. So you just figure out what is the arc cosine of 12 divided by parentheses root 13 over times 4. So this is 33.69 degrees. And you do not need to worry about what quadrant is this line. Remember last time when you do the question, tangent theta equals to second over first component, you're going to figure out what quadrant. This one you do not need to. So this is a good thing about this. It's a bit more work here. It's actually a bit more work than the tangent theta, because tangent is just the second component over the first component. But this one has, you do not worry about getting it wrong. The only thing you need to watch out here, class, is make sure you have to put parentheses on your when you calculate this in your calculator, because they are in everything in denominator. So a lot of students get this one wrong because they forgot to put parentheses down there. Okay. Usually in these sections, we use everything in terms of degrees. So sometimes your online homework will ask you in radian, then you just need to change your mode to radian in this case. Okay. We'll do one last question here. Question C, 4C here. Again, you need to find the angles in this case. So in order for you to find the angles, you have to use the formula that we just did. So cosine theta equals to U dot V over by the magnitude of U times the magnitude of V. And then make sure you put parentheses underneath it. So we got U in this case is this cosine pi over 4 times I. Now we can change this into a component form. And we know cosine pi over 4 is 45 degrees, is root 2 over 2 and root 2 over 2. Vector V in this case, we can also change this into component form. Cosine 90 degrees, cosine 90 degrees is 0. And sine 90 degrees is 1, because 90 degrees is up 1 if you look at your unit circles. So now we need to do the U dot V. So U dot V means you multiply the first component, you get 0. And you multiply the second component, you get 2 over 2. And you add that. So this times 0 is 0, this times 1 is 2. So your U dot V is 2 over 2. Next, we need to find what is the magnitude of U. So you have to square this plus the square this, and then you add up. Now, when you square this fellow, the square and square will cancel. You get 2 over 4, because this will cancel, become 2, and 2 squared become 4. And we know 2 over 4 can be reduced to become 1/2. Plus, we square this, and guess what? Squaring this is also the same as squaring the first one, so it's 1/2. So you get 1. Half plus half is 1, and the square of 1 is 1. So the what we have is the absolute value of U in this case is 1. Now we do the absolute value of the magnitude of V. So that is taking this square plus that square. So 0 square is still 0. 1 square is still 1, so you still get 1. Okay, and this one, 1 times 1 is redundant because you get 1. And anything over 1, you get back the same thing. So this is actually is root 2 over 2. But don't forget, we need to move the cosine over because it's solving for theta. So you will get the arc cosine of it. So theta in this case is arc cosine of root 2 over 2. That will be 45 degrees. Okay, so this answer is going to be 45 degrees. So again, just use your calculator. I think this, yeah, arc cosine root 2 over 2 is 45 degrees. So that is your answer in this case. So if the question is given you in the IJ form or given you in a direction form, just change it into a component form. And then after that, you just do the dot products, U dot V, and then do the U and the V in this case. Okay. I think the last thing that we talk about here is to figure out, are they orthogonal? So it's very easy to figure out if a question is orthogonal or not, is you dot it. And if the dot of this is 0, it's orthogonal. This is very simple. So I like question number 7a. If the question wants you to figure out if u dot v is orthogonal, what you do is multiply them, dot it out. So u in this case is 315. It's the last one we're going to talk about. And v in this case is -15. So in order for us to figure out is these two orthogonal, so we just dot it out. So u dot v. So 3 times -1 is -3 plus 5, 15 times 5, this is 65. And we know this is not equal to 0. -3 plus 65 is not equal to 0. So that means that u and v are not, vector u and vector v are not orthogonal. Okay, that is how easy to do orthogonal, is just dot it out and make sure if it's equal to 0, it's orthogonal. If it's not equal to 0, it is not orthogonal. So very simple type questions here. Formulas is the one that a lot of students struggle with. And as you know that I allowed you to use a formula here. And we don't do all this. We don't do the directions. We don't talk about projections and the work here. So don't worry about this. You won't see this in your test. Okay. So the orthogonal is where we stop in this section. So you don't need to worry about doing all these component forms and projections and other work, definition of work. So so this is the end for today's class. I know I burned out a little bit more here. So if you have any questions, let me know. Otherwise, you may leave the class here.